Elon Musk has given up on solar power on Earth. What if the man who promised to save the planet with solar energy is now betting that the planet itself is the problem? Elon Musk built an empire telling the world we could power everything: cars, homes, cities, with sunshine. He wrote it down, published it, called it a master plan. And now, one of his own companies is running on dozens of unregulated natural gas turbines, with nearly $3 billion more in fossil fuel infrastructure on the way. Welcome to USA Grid Mechanics, where we follow the electrons. And today, those electrons are telling a very different story than the one we were sold. Part 1. To understand just how dramatic this shift is, you have to go back to where it all started. Over the past 2 decades, Elon Musk has published 4 separate master plans through Tesla, long-form strategic documents that laid out his vision for how humanity transitions away from fossil fuels and into a clean, electrified future. The language in these documents wasn't vague corporate talk. It was bold, sweeping, and deeply ideological. In the very first master plan, Musk wrote that the entire overarching purpose of Tesla Motors was to help speed up the transition from what he called a mine-and-burn hydrocarbon economy toward a solar-electric economy. That phrase, solar-electric economy, wasn't marketing fluff. It was a philosophical commitment. It shaped Tesla's product roadmap, its acquisitions, and its public identity for years.
Tesla didn't just make cars, it bought SolarCity.
It developed the Powerwall and the Megapack. It built an entire energy division designed to capture sunlight and store it at scale, from individual homes all the way up to grid-level infrastructure. Then, just 3 years ago, in 2022, Tesla published Master Plan Part 3, an exhaustively detailed document that laid out step-by-step a credible pathway to eliminating fossil fuels from the global economy. It addressed transportation, industrial heat, building electrification, and power generation. It wasn't a dream. It was an engineering argument, and for people who had followed this space for years, it felt like a genuine milestone, the moment when the clean energy transition stopped being a talking point and started looking like a technical blueprint. So with all of that context firmly in place, pause for a second and ask yourself, how did we get here? If you've been following the energy transition and something about this story feels off to you, you are not alone, and you are not wrong. Drop a comment below and tell us, do you think Musk has genuinely changed direction? Or is this just a temporary detour on the way to something bigger? We read every single comment on this channel, and this conversation matters. Part 2, here's where things get uncomfortable. xAI, Musk's artificial intelligence company and the developer of the Grok AI system, has built out its flagship data center, called the Colossus supercluster, in Memphis, Tennessee. And the way that facility is being powered has raised serious red flags among energy analysts, environmental regulators, and clean energy advocates alike. According to reports, xAI brought dozens of natural gas turbines online to power the facility, many of them operating without the standard environmental permits that would typically be required. Local residents and environmental groups raised alarms about air quality, particularly in a community that already bears a disproportionate share of industrial pollution. This wasn't a minor infrastructure footnote. It was a significant regulatory controversy that put xAI and Musk directly at odds with the kind of clean energy values Tesla had spent years championing. And rather than treating this as a problem to be corrected quickly, xAI appears to be doubling down. The recently filed SpaceX IPO documents, which are remarkable reading for anyone interested in the future of energy and AI, reveal that xAI has plans to purchase an additional $2.8 billion worth of natural gas infrastructure. That's not a stopgap. That's a strategic commitment to fossil fuel-powered computing, at least for the foreseeable future. Now, to be fair, there are some clean energy elements in the picture. xAI has spent approximately $697 million over the last 2 years purchasing Tesla Megapacks, the large-scale battery storage systems that Tesla manufactures for grid applications. These Megapacks are genuinely useful technology. They allow data centers to manage peak electricity demand, smooth out grid fluctuations, and reduce strain on the broader power network. SpaceX, meanwhile, has spent around $131 million purchasing 1,279 Cybertrucks, another intra-Musk transaction that keeps capital circulating among his portfolio of companies. These kinds of related party transactions are worth watching because they shape which technologies get funded and which don't. But here is the telling detail. Despite Tesla having a fully developed, commercially available solar energy product line, xAI has not made any materially significant purchases of Tesla's solar panels for its data centers. The Megapacks are there, the Cybertrucks are there, the solar, nowhere to be found, at least not on Earth. Part 3. This is where the SpaceX IPO filing becomes genuinely fascinating and genuinely strange. Solar power isn't absent from SpaceX's vision of the future. It's just been relocated, off the ground, out of the atmosphere, and into orbit. The filing makes a strong technical case for space-based solar power. The core argument is straightforward. Solar panels in low Earth orbit or beyond receive sunlight continuously, 24 hours a day, 7 days a week, without interference from weather, seasons, or the day-night cycle. SpaceX claims that space-based solar arrays can generate more than 5 times the energy output of equivalent terrestrial installations. And in theory, that energy could be beamed back to Earth as microwaves or laser light, then converted back into electricity on the ground. This isn't a new idea. Aerospace engineers have been discussing space-based solar power since the 1970s. But Musk and SpaceX are now treating it as a near-term operational goal rather than a distant theoretical possibility. And they're connecting it explicitly to the AI data center problem. The reasoning goes like this. AI model training requires enormous, sustained amounts of computing power. Computing power requires electricity, and the demand for both is growing so fast that it's beginning to outpace what terrestrial energy infrastructure, even with aggressive solar, wind, and storage build-out, can realistically provide at the speed required. Rather than fight that constraint, SpaceX wants to eliminate it by moving the data centers themselves into space, powered by that round-the-clock orbital sunshine. Several other Silicon Valley executives have started echoing similar ideas. The concept of server farms in orbit, freed from land use restrictions, local opposition, grid capacity limits, and permitting delays, has obvious appeal to people whose primary constraint is speed of deployment. When you can't build fast enough on the ground, build above it. Power prices aboard Starlink satellites are already many multiples higher than what a typical terrestrial data center pays per kilowatt hour. And that gap doesn't close easily, because every solar panel, every chip, every cooling system, and every piece of structural hardware has to survive the radiation environment of space, which degrades electronics significantly faster than ground-level conditions do. There's also a fundamental architectural question that nobody has cleanly answered yet. Can AI training workloads, which often require extremely low-latency communication between thousands of processors working in tight coordination, actually be distributed across multiple satellites orbiting at thousands of miles per hour relative to each other? The answer right now is not clearly, which means a substantial portion of serious AI compute may remain Earthbound regardless of what SpaceX builds in orbit. We want to know what you think about space-based solar, genuinely. Is this visionary infrastructure thinking, or is it the most expensive way in human history to avoid a zoning board? Hit the like button if you think terrestrial solar still has a massive untapped role to play, and tell us in the comments what you think the real bottleneck is for clean energy data centers. Your perspective shapes what we cover next. Part 4. Understanding why Musk has arrived at this position requires understanding how he thinks. Specifically, his much-discussed first principles reasoning approach. The idea is to strip away assumptions and conventional wisdom, identify the most fundamental truths about a system, and build your conclusions up from there, rather than reasoning by analogy from what already exists. Applied to AI energy demand, Musk's first principles conclusion, as stated directly in the SpaceX SEC filing, is that global AI compute requirements are growing at terawatt-scale annual rates. Let that land for a moment. A terawatt is 1 trillion watts. All of the world's data centers combined, running everything from cloud computing to streaming video to financial systems to AI workloads.
currently consumes somewhere around 40 gigawatts of continuous power.
Musk is suggesting that AI alone could add a full terawatt, 25 times the current total data center load, every single year. The filing goes further, arguing that standard third-party estimates of data center power demand are systematically too low because those estimates are anchored in the constraints of terrestrial infrastructure, rather than unconstrained demand projections. In other words, analysts are underestimating how much power AI will need because they're modeling what can realistically be built, not what AI might actually consume if supply were unlimited. Is this plausible? Technically, yes. AI training has been in a phase of rapid exponential scaling, and history has repeatedly shown that technology adoption curves surprise pessimists, but exponential growth curves also level off. The question is when, and nobody, including Musk, can answer that with confidence today. What's clear is that this framing conveniently justifies both the natural gas spending and the space ambitions. If terrestrial infrastructure is fundamentally inadequate no matter what, then there's no point optimizing it. You just need to get off the ground as fast as possible. The argument is elegant. Whether it's correct is another matter entirely. Meanwhile, back on Earth, the numbers tell a more grounded story about solar's potential. The amount of sunlight that strikes Earth's surface every hour contains more energy than humanity uses in an entire year. Utility-scale solar installations are now among the cheapest sources of electricity ever built, with costs having dropped by over 90% in the last 15 years. The United States alone has permitted and is developing hundreds of gigawatts of new solar capacity. The technology works. The economics work. The constraint is permitting speed, grid interconnection queues, and transmission infrastructure, not fundamental physical limits. Part 5. Here's what makes this story so important for anyone who thinks seriously about energy infrastructure. Elon Musk is not a peripheral figure in the clean energy transition. Through Tesla, he has arguably done more than any other single private actor to accelerate the adoption of electric vehicles and grid-scale battery storage worldwide. Tesla's Megapacks are installed on every continent. Tesla EVs have pushed every major automaker to electrify their fleets years ahead of schedule. The influence is real and substantial, which is exactly why the choices being made at xAI carry so much weight. When the person most publicly associated with clean energy builds a flagship AI facility on natural gas, without permits, in an environmental justice community, and then commits nearly $3 billion more to that same infrastructure, it sends a signal. It tells other AI companies, other data center developers, and other grid planners that fossil fuel power for AI is not just acceptable. It's what the leading edge looks like. There's also a harder question lurking here about capital allocation. Tesla's energy division has some of the most mature, scalable clean energy products available in the commercial market today. Solar panels, Megapacks, inverters, grid software, all of it exists and works at scale. If xAI were purchasing Tesla Solar at the same scale it's purchasing Tesla Megapacks, it would be providing enormous revenue to the clean energy side of the Musk portfolio, while simultaneously demonstrating to the broader tech industry that AI and solar are compatible at hyperscale. That's not happening. Instead, we have a situation where the Megapacks are being used to manage peaks on a grid that's being charged primarily by gas turbines. The battery stores the fossil energy, but it doesn't replace it. That's a fundamentally different use case than a fully renewable powered data center, and the distinction matters. Here's the question we're leaving you with today, and we genuinely want to hear your answer. If a company like xAI committed to pairing its Megapack purchases with equivalent investment in solar generation, could it power a hyperscale AI data center entirely on clean energy today? Or are there real technical barriers we haven't solved yet? Leave your take in the comments. Subscribe to USA Grid Mechanics if you want to keep going deep on exactly these questions every week, because this conversation is just getting started. 3 years ago, the Tesla Master Plan Part 3 described a credible, technically grounded path to eliminating fossil fuels from the global economy. It was one of the more serious documents to come out of Silicon Valley in years. A reasonable place to begin delivering on that promise would have been xAI's own data centers. right there under Musk's direct control, funded by his own capital, buying from his own supply chain. Instead, the orbital dreams are getting the investment, and the gas turbines are getting the contracts. The perfect doesn't have to be the enemy of the good. Space-based solar may well be part of humanity's long-term energy future, genuinely. But we've barely scratched the surface of what terrestrial solar can do. And the grid is being built right now, with decisions being locked in for decades. Every megawatt of gas infrastructure that gets installed today is infrastructure that has to be retired early if we're serious about the climate commitments that were made, in writing, just 3 years ago. The electrons don't lie. We'll keep following them. See you next on USA Grid Mechanics.